Hello everyone, welcome back to the channel Mining Engineering. I am Satyavrata. Today is the second video lecture on the topic Sobel, and in this lecture we will discuss some more numerical problem of Sobel. In the previous lecture we have discussed the performance of the Sobel and we have discussed one example. Now we will discuss one more problem, one more similar kind of problem. Determine the capacity of a Sobel if the capacity of the bucket is 3 meter cube. The average time cycle is found to be 45 seconds. The bucket fill factor is 0.8 and the bulk density of the material is 1.5. Determine hourly capacity of the shovel if the effective loading hour utilization is 50%. Let's solve this problem. The bucket capacity of the shovel is given, that is 3 meter cube is given here. Next, the fill factor is given, that is 0.8. It will take 80% of 3 meter cube material. The bucket size is 3 meter cube, but the bucket is filled up 80%. So it will take 2.4 meter cube material. Now let's convert volume to tonnage. We have the bulk density here. Now multiplying the density with the volume, here the meter and meter will be cancelled and the tonnage will be 3.6 ton. So the shovel can hold 5.4 ton of material per load. Per load, time taken is 30 seconds. It is given in the question. The time cycle is 30 seconds. That means in 30 seconds, the shovel can load 5.4 ton of material. We need to find out hourly production. So in 45 seconds, material production is 3.6 ton. So in 1 hour, that is 3600 seconds, the material production will be 288 ton per hour. However, in the question it is given the effective hour utilization is 50%. That means we are utilizing the shovel only 50%. That means the shovel is not utilized the total time of 1 hour. So the hourly production will be 288 into 0.5, that is 144 ton per hour. As per the formula, we can also calculate the same thing. Actually, the formula is derived by compiling all these steps. Here the production P is equal to, like we are multiplying there the bucket capacity into the fill factor 0.8 into, this is the meter cube, the bucket capacity is given in meter cube in volume. So now we are multiplying with the density, then it will give the tonnage. Now that cycle time we are dividing here, that means in 45 second per the shovel is loading per load in 45 seconds. So in 1 second, and we are multiplying with hourly 3600 seconds. So whatever steps we have calculated there in that formula, all steps are compiled here. Here we'll get all the steps, and here we are multiplying 0.5, that is our hourly utilization is 50%. So by utilizing the formula also you will get the same answer. We will discuss one more problem here. A coal mine is planning to excavate 40 million tons of coal with a stripping ratio of 3 meter cube per ton of overburden. The in situ specific gravity of coal is 1.4 and the overburden is 2.5. Here the specific gravity of the coal and the overburden is given, and on blasting the volume is swelled 1.2 times, that is the swelling factor, for both overburden and coal. The bucket fill factor is 0.8 for overburden and 1 for coal. Find the number of shovel required for overburden and coal if 42 meter cube shovel is chosen for overburden and 20 meter cube shovel is chosen for coal. Consider the shovel cycle time of 1 minute and effective loading hour of 4000 hour per year. This is 4000 hour per year. Now let's solve this question. The annual production target is given, that is a coal mine is planning to excavate 40 million ton of coal. So the annual production target of the coal is 40 million ton. 1 million is 10 to the power 6, 10 lakhs. So 40 into 10 to the power 6 ton. That is our hourly production target of coal. The stripping ratio is given, that is 3 meter cube per ton. That means after excavating 3 meter cube of overburden, we are getting 1 ton of coal. So for getting 40 into 10 to the power 6 ton of coal, we need to excavate 40 into 10 to the power 6 into 3, 12 into 10 to the power 7 meter cube of overburden. Shovel used for coal removal. There are two types of shovels were used for removing coal and for removing overburden. 20 meter cube of shovel is chosen for coal and 42 meter cube of shovel is chosen for the overburden. Now let's calculate for the coal. Bucket size is given. The bucket size is given, that is 20 meter cube, and we will calculate the production of the shovel. Specific gravity is given 1.4. The specific gravity is the density of the material divided by the density of the water. Density of the material, that is the bulk density, and we know the density of the water is always 1. So specific gravity is the comparison of the density of that material with the density of the water. So while we are mentioning the specific gravity, here the unit is not written because we are dividing that thing by 1 ton per meter cube. Density of the water is always 1 ton per meter cube, and we are dividing the density of the material with the density of the water. Density of the water is 1 ton per meter cube. So here in specific, while we are writing specific gravity, the unit is not mentioned. So that is 1.4. Bucket fill factor is 0.8. Swelling factor is given, that is 1.2 due to the blasting. Cycle time is 1 minute. So the quantity of coal per bucket is called bucket capacity into the fill factor. So quantity of coal per bucket is equal to bucket capacity into fill factor. Bucket capacity is 20 meter cube and the fill factor is 0.8. So the quantity of coal per bucket is 16 meter cube. But there is a swelling factor of coal is there, that is 1.2. That is, material is swelled after blasting or excavate. There is the in situ material, and when we are doing blasting, we are excavating that material. The material is swelled by 1.2 factor. That means the bucket can hold 16 meter cube of material in its bucket, but due to swelling factor, 16 meter cube of material will become 19.2 meter cube because of the swelling. So how much material should that shovel take so that it will become 16 meter cube after swelling? So our bucket size is limited, that is 16 meter cube, that our bucket can hold only 16 meter cube of material. But if we take 16 meter cube of material, after swelling it will become more. So we should take less amount of material so that after swelling it will become 16 meter cube. So at 1.2 swelling factor, the quantity of coal should be 16 meter cube. So at 1 swelling factor, the quantity will be 13.3 meter cube. So ton of material can take per bucket So this much 13.3 metric cube of material the shovel can hold in its bucket, because after swelling it will become 16 meter cube. So this much material is there. Again we are multiplying with the density to get the tonnage of the material. That will be 18.6 ton. Cycle time is given 1 minute. So in 1 minute the shovel can take 18.6 ton of material. So the hourly production will be into 60, because this much material can be produced in 1 minute. So in 60 minutes the shovel can produce 1116 ton of coal. So the yearly production will be here it is given effective loading hour per year. Per year we are getting 4000 hours. So this is hourly production, and then we are multiplying with the total hour in a year. So we will get the total yearly production from that shovel. Our target is 40 million ton, and by implementing one shovel we are getting this much tonnage of material. So we are not achieving our target, so we need to implement more number of shovel. So number of shovel required equal to 40 million ton divided by this value. So it's around 8.9. So we need at least 9 numbers of shovel for achieving 40 million ton of production target of coal. Now we will calculate the same thing for the overburden. Shovel used for OB removal. The bucket size is given in the question, that is 42 meter cube. Specific gravity of the OB is 2.5. Bucket fill factor is 0.8. Swelling factor is 1.2. Cycle time is given 1 minute. So the quantity of OB per bucket equal to bucket capacity into the fill factor. Bucket capacity is 42 into 0.8 is the fill factor. That will be 33.6 meter cube. Now the swelling factor is given. So actual quantity of OB per bucket equal to bucket capacity into fill factor by the swelling factor equal to 28 meter cube. The actual quantity of OB that shovel can take in its bucket is equal to 28 meter cube. Cycle time is given 1 minute. So in hourly production will be into 60, that will be 1680 meter cube. And yearly production from one shovel will be effective hour per year is given. So we're multiplying 4000. So that will be this much amount of meter cube. This is the yearly production per shovel. However, our target is 12 into 10 to the power 7 meter cube, as we have calculated from that stripping ratio. So the number of shovel required is equal to this value, our yearly production value, divided by the amount which is produced from one shovel. That will be 17.85. So let always take the next higher value, because if you take the 17 number of shovel, it cannot achieve that target. It needs at least 17.85, and the fraction number of shovel we cannot implement. So that's why always your answer will be the next higher number. So 18 will be the correct answer. So 18 number of shovels we need to implement for achieving the yearly production target which is given in the question. Thank you. We'll see some more numerical in the next video.